Hey all, welcome to another flipped classroom. Today we're going to be continuing on our equations, and we're going to be focused on writing equations and representing situations. So yesterday you learned about a one-step solution, if you will. You learned about using inverse operations and used all those to kind of solve it. Today, you're not going to do so much solving as you will do writing and expressing. So it'll give you like a word problem, and then you will have to write an equation based off that word problem. It will also give you some options for a solution. So like this first part is you're going to determine whether values are our solution. So it'll tell you like, I think the value is this, and you're going to have to plug it into the equation, and you're going to have to prove that statement to either be true or false. Okay? So remember, you can rewind this as many times as you want, pause me whenever you want. The more you write in your math book, the better off it's going to be. Remember, these are always open note tests. So let's get started. So an equation, I'm just going to read this up here. An equation is a mathematical statement that two expressions are equal. An equation may or may not contain variables. For an equation that it has a variable, a solution of the equation is the value of the variable that makes the equation true. So yesterday when we did those equations, I told you to take your answer and plug it back in for your variable. So example being like if we had 3x equals 9, we would use the other inverse operation, so it's being multiplied. So inverse would tell us we are going to divide. Whatever you do to one side, you do to the other. So x equals, and 9 divided by 3 is 3. Okay, what I told you yesterday is, okay, to check this, you're going to take this 3 and plug it back in for x, and you'll use the original equation. So 3 times, which we think x is 3, 3 times 3 is 9. That makes this statement true. Okay, so that's what we're going to do today. All right. So an expression represents a single value. So an expression, a numerical expression, would look like 5 divided by 4. All right, in words, it would say a number plus, oh, I'm sorry, that's a plus sign. I'm sorry. And then words would say a number plus 4. An algebraic expression would say n plus 4. All right. So, and in an equation, the difference is now we have an equal sign. And we're comparing the two. Remember the teeter-totter. Like 5 plus 4 weighs the same as 9. We got to keep that teeter-totter equal. So let's get into this. So we're going to determine whether these are true or false. So it says determine whether the given value is a solution of the equation. So our math problem is x plus 9 equals 15. Well, this is just like what you did the other day. Now it's saying x is equal to 6. Okay, so we're going to plug that back in our equation. And if that equation at any point isn't true, it's not a solution. So let's just plug it in. So instead of x, we're going to write 6. So 6 plus 9 equals, well, I know my math facts. I can count up 10, 11, 12, 13, 14, 15. X equals 15. So x, or 6, I'm sorry, is a solution. So what they weren't lying to us. They weren't trying to trick us. It's true. It works. So we can prove that. The next one is y divided by 4 equals 32. So again, you're going to plug, instead of y, you're going to say y equals 8. So if you plug 8 in for y, 8 divided by 4, is 8 divided by 4 32? It's not. So 8 divided by 4 is actually 2, not 32. So 8 is not a solution. They're going to try to trick you. You got to be able to, they want to know if you can solve it. I want to know if you can plug it in and tell me whether the statement is true or not. Okay, last one, 8x. Remember, it's being multiplied, equals 72, x equals 9. So now we'll just go 8 times 9. We're plugging 9 in for x. 8 times 9 is 72. So 9, oh, I'm sorry. I don't know where that came from. So 9 is a solution. Okay, so that's what we're looking at here. We're trying to decide whether or not a given value, so GoMath's going to give you a value, or I'm going to give you a value. You need to tell me whether it's a solution. All right. So let's go to the next page. So same thing. You're going to do 1, 2, 3, and 4. You're going to do the exact same thing. You're going to determine whether the given value is a solution. All right. So all you need to do is I'm looking for you to rewrite the equations, except now instead of using a variable, you're going to use the given value. And then all I need to see from you is the new equation and a yes or a no. Okay, so you're going to rewrite this equation with 5 instead of n, and you're going to tell me, yes, this is a solution, or no, it's not, because 5 plus 6, it does or does not equal 11. Hint, hint. So pause now, and then when you're done, unpause it, and we'll talk about it. So pause it now. Okay, so after that, hopefully, here's what we've got. We're going to plug 5 back in for n. So 11 equals 5 plus 6. That's a yes. That's true. Y equals 18. 18 minus 6 equals 24. Not in my world. Nope. X equals 36. 36 divided by 9 equals 4. Yes. 15 times t equals 100. Instead of t, we're going to use 6. 15 times 6, does that equal 100? Oh, not in my book it doesn't. Well, let's see. 15 and 6. 6 times 5. Gosh dang it, I keep doing that. 15 times 6 is 30. 6 times 1 is 6, plus 3 is 9. So that is a, what is happening? Why does it keep doing that? That's a no. Okay? So that's the first part of today's lesson. The second part is writing equations. So if you need to watch that part again, go ahead and do so now. If you're like, yeah, I get it, I'm substituting, it's the same thing I did last time, now I'm just telling you whether it's true or not, perfect. Let's move on. Okay? So the next part is going to be, you're going to get these big, nasty word problems, and then you're going to have to turn them into a math problem. It's simple as that. Okay? So, Mark scored 17 points for the home team in a basketball game. Okay? His teammates, as a group, scored P points. Write an equation to represent the situation. So they do a great job here. Mark scored 17 points. That's our constant, meaning it never changes. There's 17. His teammates as a group scored P points. Well, we don't know how many points they scored, but we're going to take Mark's points plus his teammates' points, which it already told us to. Right here, it's P. And they're going to equal what? Well, his teammates as a group scored P points. Write equation to represent the situation. Total points equals 46 based off our diagram here. Okay? So there's our math problem. You're not solving. All it's asking for is for you to tell me what the equation would be. All right? So let's try number 5, and then when we're done with number 5, I'm going to have you do 6, 7, and 8 on your own. Okay? So here's our math problem. This is why it's important that you underline important information so that we know what to use. Marilyn has a fish tank that contains 38 fish. Oh, I almost deleted that. Okay? There are 9 goldfish and F other fish. All right? So 38 is our total. I always like to start there. Okay? So 38 total fish. So that's going to be on its own side of the equation. Okay? Remember our teeter-totter. So of those fish, 9 are gold. And then we're going to be adding these fish together to get our total, right? So the other one must be F. So my equation is 38 equals 9 plus F. All right? Anytime you hear like groups of or divided equally, that's when you're going to kind of go, oh, I'm going to divide. Or groups of. Of tells us we're going to multiply. Or difference or something like that. Those are the key words that we talked about earlier in the year that you're going to look for to help you decide what you're going to do. Are you adding, subtracting, multiplying, or dividing? The key thing I like to do here first is always find the whole number first. Always try to find the total, because in every equation there's going to be in the total. Okay, so let's do 6 together, and then I'll let you do 7 and 8. I've already changed my mind. Juanita has 102 beats. Boom, bingo. There is our total. So I'm going to write it up here so we have more room. 102 is our total. Oh my gosh, that's disgusting. All right, 102. And we know it's a total, so it's on its own side of the equation, okay? To make n necklaces, each necklace will have 17 beads. All right, so I'm making n necklaces, and each of those necklaces has to have 17. Oh. What do you think we're going to do? Well, sounds like groups of things, right? Sounds like each necklace is going to have a certain amount. So I'm thinking it's going to be n times 17. Okay? We don't know how many necklaces they're going to make, but each necklace has to have 17 beads. Okay? All right, so I want you to pause 7 and 8, and when you're done with 7 and 8, unpause it, and we'll start talking about that one. Welcome back. So hopefully you work this through. 7's a doozy, man. I like 7, okay? So C will never be on its own side until you do things. So here's the tricky piece here is, so Craig is all by himself, okay? And I know it's weird because it gave it to you in a different order, but Craig is C years old, all right? His friend is 12, but she is 3 years younger than Craig. So if you were to do this, you would add this to 3. You'd add 3 on this side, and you add 3 on this side, you get 15C. 15 minus 3 is 12, okay? So this is your equation for 7. I don't know why this keeps happening. Sorry, guys. All right, so number 8, so this is 7. Okay, now here is 8. This one's pretty easy. So Kim rented, she paid $8. Okay, so she paid $8 total. It says that at the bottom. Okay, so Kim rented skates for 8 hours. The rental fee was $2 per hour. Per should be a hint. We're multiplying. Boom, right? I rented skates for this many hours. At this cost, I pay 8. So $8 at $2 per hour. Okay? So these are tough. I won't lie to you. This is probably a tougher concept than most of us are comfortable with. Okay? So here's another great example to see whether or not you have done the right work. You'll do the same thing. You'll read the equation. You'll read the problem. You'll set up the equation. You'll solve the equation, and then you'll tell yourself whether you did it right or wrong. Okay? So if you need an example, I'll let you read this page on your own. Okay? So here's what we're going to do. We're going to dive into guided practice. All right? So you're going to pause me when you're done, or stop listening to me, period. Then you're going to move on to the guided practice on page 300. Once you're done with page 300, you're going to raise your hand. Okay? Most likely what I'll have an answer key. You'll go and check your work. If you get anything wrong, go back and fix it. Once I've given you the green light that everything looks good, you've completed the guided practice, there's no questions, you can move on to the independent practice. This is tough stuff. But remember, we've talked about that. We need to work on tough stuff so that we become better at what we do. Okay? So you can use scratch paper, you can use a whiteboard, but I think most of your stuff can be done right here. But if you need extra space, feel free. Remember, I'm here. I'll work with you. It's not like you can't raise your hand and ask a question. If you have a question, raise your hand and I'll help you. Replay this if you have to. If you don't have to, good luck. Get to work. I hope you enjoyed our flipped classroom. I know you guys usually like it. And good luck. Remember, if you need any help, just ask. Okay? Enjoy.